everyone, welcome back to another episode of Virtual MOSI. My name's Jose and this is Weather Week. Now behind me we have our wonderful kind of mural or backdrop that has been with us the entire time. It was drawn by one of our in-house artists, as you can see, very, very talented. And there's some keywords on this board that we've been covering with all of our videos up to date. So we've talked about pressure, we've talked about heat, we talked about water, we've talked about all of these things, and today is actually when we get a chance to put all of them together and learn about the weather forecast. So that's really kind of the goal for today, to learn how scientists actually are able to come up with the weather forecast that we see on our phones, or maybe we ask Alexa or anything that might work in your house to give you the weather forecast. So let's go ahead and dive into it. First things first, let's remember that pressure is actually something that very, very much impacts our weather patterns. As you might recall from our experiment with the bottle and we kept pumping air into it, the higher the pressure, the lower the chance that we're going to see some clouds or condensation form inside the bottle. And yet when we open that valve, then suddenly the low pressure causes those droplets to condensate or come together, and then we have a lot of clouds. The same holds true for our clouds in the atmosphere. It's just a much larger version than what you see in the bottles. As for the water, well, we talked about the water cycle and how the water evaporates from lakes, rivers, and streams, how it goes and forms clouds up in the atmosphere, and eventually, when all the water in those clouds just is too much for the cloud to hold on to, the water precipitates and it falls back down to the earth, where it eventually will seep through the cracks in the soil and the rocks, and it feeds back into the lakes, streams, and rivers, and the cycle repeats itself. And of course, all of that is driven by heat. The primary heat source for all of this is actually the sun. Yes, that giant, well, it's a dwarf star that's about 93 million miles away. That is what's responsible for our weather patterns. But how does all of this translate into something that we can see on our phone? Well, it turns out that in recent decades, scientists have actually been sending out more and more satellites into our atmosphere, and those satellites are constantly peering down to take a look at the weather patterns on Earth. There are specific instruments that we also have on buoys on the ocean that are measuring the temperature of the water, the temperature of the air, also wind speed, and also the pressure and all humidity, all sorts of really interesting data that drives all of the forecasting systems. And then what scientists do is they take all of that data from all of those sources and they feed it into supercomputers. So there's plenty of supercomputers constantly crunching out those numbers, trying to come up with an accurate model or a prediction of what the weather will be that day. Obviously, it's not going to be a perfect prediction because we can't predict the weather. There's a running joke that being a weather person is actually the only job where you can be wrong all the time and still have a job. So you can't really fully ever predict the weather, but you can come really, really close. And in recent decades, we've gotten much and much better. It turns out that our weather predictions today are actually a full day farther out better than they were 10 years ago. That means that our 5-day forecast is actually more accurate than the 4-day forecast from 2010. And it's 2 days more accurate than, say, a 3-day forecast from the year 2000. And why do you think that is? Well, because we've been sending more satellites, so now there's more instruments that can give more data to the computers, and the computers themselves have gotten faster and are able to process much more information much more easily. So thankfully, we now live in an era where it's easier to perform these calculations. Now, let's go ahead and take a look at how all of this can somehow translate to a weather forecast that we can see on television. When you're watching the newscaster on TV, you don't typically see them just in front of a random backdrop that you can touch. Instead, it's often a virtual backdrop, and it's more often than not kind of animated. It has some cool icons, and I'm going to show you how we can do that using a simple green screen. So what you see on this side is a green screen, and the real term for it is a chroma key screen. Essentially, the computer will see this color, and it will realize that it looks absolutely nothing like my face or anything that I'm wearing today. So I did make sure not to wear the color green. Otherwise, some weird things would happen. But the computer can see this color independently from the rest. And what will happen in that case is that the computer will say, okay, the green backdrop is something that we don't want to be there. And what occurs is that it can replace that backdrop with any image. And as you can see, I've got an iPad right here. In an actual news studio, this would be a regular broadcasting camera. Here at MOSI, we're going to use an iPad for simplicity's sake. It's also something that you could use at home. So stay tuned if you want to figure out how you can play the role of a weather person, a meteorologist. Now, I've opened up our application here, which is conveniently named Green Screen. If you're interested, it is actually a paid application made by Do Inc., but there exist alternatives which work just as well. This one just happens to be my favorite. I've used it for quite some time. And what I've done is I've created this totally accurate weather forecast. There's a winky face there for a reason. And we've set that as our static image in the backdrop. So this is the iPad. This is me standing in front of this green screen. And what is happening in the software is actually the iPad is isolating me from this backdrop because it realizes that the colors are totally different. And what that means for us is that we can now superimpose our image independent of this background and change the background to whatever we want. In this case, our forecast. So if you look on the big screen here, you'll notice that I am actually now being projected in front of the backdrop that you saw earlier. And if I were a meteorologist, I would say something along the lines of, hello, thank you for tuning in. Let's talk about today's weather. As you can see, we have the weather for Saturday here. We have some thunderstorms, as you can see in our icon here. We have a high temperature of 63, a low of 41. We will then move on to our Sunday's forecast. And then Monday, Tuesday, you'll find that the weather kind of clears up a little bit. It gets a little bit more sunny. And as we move on throughout the week, you'll see a tiny spike in temperatures. Now, I am doing this by physically pointing at a blank green wall. But the software is actually taking both of those images and putting them into one. So they are merging those images, and that's how you're able to see the newscaster pointing out the different days of the week, the different icons for the weather, the different temperatures. So it's actually really, really cool, very, very interesting. And again, it's something that you can do at home if you download a green screen software. Like I said, there's plenty of them out there. This one is arguably my favorite, and it's super, super simple to use. Now, let's go ahead and talk a little bit more about how you would create this if you're at home. The very, very first thing you need to do is have an image. For now, this image is, of course, our backdrop, but you can add any image that you choose. All I've done is I've tapped the tiny plus sign. I can select from all of our photos. Here's some photos that we've got saved on our camera roll here. If I wanted to be in front of some really cool sci-fi buildings, I could do just that, just as easily. So it's really the chroma key technology that can make this work. But again, we want this to be our weather forecast. And then the next channel is actually what we want, which in this case will just be a camera. And when you add the camera, that's when you're able to see what the iPad sees and isolate that from the screen. Now, you don't need to have a tablet. There's plenty of applications that work just as well on a mobile device, and they can all help you be the meteorologist. So it's actually really, really cool. And let's not forget, the whole weather prediction is still just a prediction. So when you go outside and you're like, I thought it was supposed to be cloudy today. And you look up, and it's really, really sunny. Remember, it's just a prediction, and while it is arguably easier to predict things like temperature, humidity, and precipitation, it is far more difficult to predict phenomena with which here in Florida we are very, very accustomed to. That's right, it's difficult to predict hurricanes. If we kind of go back to our three main points here, pressure, water, and heat, that's really kind of what fuels hurricanes. So hurricane systems typically are a low pressure system. Low pressure would enable a hurricane to gather more water droplets. And those water droplets, that water vapor, also has a lot of heat associated with it because it's just been evaporated off the ocean. That's why when a storm makes landfall, it can't pick up as much water anymore, so it loses some of that intensity. It typically kind of peters out over a matter of days. So that's why when a hurricane or storm makes landfall, it tends to weaken. But if it's over particularly warm waters, say like the Gulf of Mexico or the Atlantic Ocean, then obviously that warm moisture is going to continue to feed the hurricane and the storms. Now, how do we know the pressure at a hurricane? Well, again, we have some buoys on the ocean that are measuring the wind speeds, the pressure and temperature and all of those things, but we also have some really interesting airplanes. And those airplanes are built to fly essentially to where the hurricane is, and they will drop what's called a drop sonde, which has some instruments that are able to measure localized wind speeds, pressure, temperature, and that gives scientists more data that, again, they can crunch on those computers, and that gives us our weather patterns. Now, I know that some of you probably have some questions, and one of the questions that I've always had is, how come anytime I'm looking at the weather pattern, there's always this big cone, right? It seems to kind of spread out. Well, it turns out that that cone typically spreads out the farther into the future you're trying to predict the weather. When you're gathering data for right here and now, you are pretty confident that those numbers are accurate. But then if you are trying to predict something that might happen in 10 minutes, those numbers, the accuracy of them goes down a little bit, and it continues to decrease the farther out you go. Now, there's another question that I've always asked myself, and it is, how come certain models show a storm moving in one direction and others moving in a completely different direction? Aren't all of the computers calculating the same data? Aren't they all working with the same numbers? And the short answer is yes, they are. It's just that different models will prioritize different aspects of that data. So some models can actually put a little bit more emphasis on pressure, while other models put more emphasis on something like wind speed, and the tiniest of changes can actually have a big impact when it comes to those types of calculations. So weather is, of course, one of those things that we can't predict, but we're getting better at it each and every year. Like I said, we have made a lot of progress in the last few decades. So I hope that you've learned a couple of things today. I hope that you've also seen one of the roles that we can have as a scientist, as a meteorologist, as someone who studies the weather and our atmosphere. I hope you've enjoyed this video, and if you have any questions, don't forget to submit those to MOSI. My name's Jose, and this is Virtual MOSI. Keep discovering, guys.